Hi everybody, my name is Rishi and today's video is going to be an introduction to differentiation. So in the last video, we learned about how limits work, but where exactly can we apply them? Well, one useful application of limits is to determine the gradient of a curve at any given point. Now, in contrast to straight line graphs that have a constant gradient, for example 2x minus 3, where the gradient is 2, curves have varying gradients at different points. So let's say we have the function x cube minus 2x square minus x plus 5. We need to find the gradient of the graph at the point x is equal to 1. And so we can use the simple gradient formula y2 minus y1 divided by x2 minus x1. So let's take a as the point on the graph whose gradient we need to find, which in this case is x is equal to 1. Now, let's take a small increment h from x is equal to 1 and take that point on the graph, naming it b. Let's start with h is equal to 1, which means that the point b is 2, 3. So the gradient of the graph is calculated to be 0. However, we can see that this is far from the actual value of the gradient. So let's take a smaller value of h, let's say 0.5. The gradient when taking these 2 points is minus 1.25. We can see that this is still not accurate enough. So if we keep on reducing the value of h and calculating the value of the gradient, we can see that the gradient is approaching minus 2. Therefore, we can conclude that the gradient of the graph at the point x is equal to 1 is equal to minus 2. But how do we do this mathematically? If we were to take the gradient of the graph using the points a and b, the gradient of the graph would be equal to f of x plus h minus f of x divided by x plus h minus x. Here h is the small increment and x is the point whose gradient we need to find. If we were to compare this to the simple gradient formula, y2 would be f of x plus h, y1 would be f of x, x2 would be h plus x, and x1 would be x. We saw that as h was approaching 0, we were getting closer and closer to the actual value for the gradient at that point. So we can say that the limit of the gradient as h approaches 0 is equal to the actual gradient of the graph at that point. After simplifying, we finally get a function m of x. And when we input x is equal to 1, we get the gradient to be minus 2 as well. We can use this function m of x to get the value of the gradient at any point. This method is known as the method of first principles. So how exactly is this connected to calculus? Well, differentiation is the process by which we can find the rate of change of a function at a point along the function with respect to one variable. And since the method of first principles allows us to find the gradient of a function, it also tells us the rate of change of the function at any point on the function with respect to one variable. We call the differentiated function the derivative of the original function. So in the previous example, the derivative of the curve x cube minus 2x square minus x plus 5 is said to be 3x square minus 4x minus 1. It is important to know that using this method of first principles, we can find the derivative of any function. The derivative of a function y can be denoted by y dash or dy by dx. While the method of first principles can be used to find the derivative of any function, it can become very tedious and time consuming, as we saw with the previous example. So, there are rules that we can use to differentiate a function quickly. In this video, we will briefly touch upon some of the basic rules. Firstly, we have the power rule, which states that if we have a function y is equal to x to the power n, where n is a constant, the derivative of y is equal to n into x to the power n minus 1. The second rule that we need to remember is that if we have a particular function y, which is obtained by the addition or subtraction of more than one function, the derivative of y will be the derivatives of those individual functions added or subtracted as well. The third rule states that if you want to find the derivative of a function f of x multiplied by a constant a, it is equal to the constant a multiplied by the derivative of the function f of x. The fourth and final rule that we will be discussing today is that the derivative of any constant a will always be 0. So let's apply these rules to the previous function. We have x cubed minus 2x squared minus x plus 5. And by using these rules to differentiate it, we get the derivative of the function to be 3x squared minus 4x minus 1, which is the same expression we got earlier. And so the gradient at the point x is equal to 1 is also minus 2. Well, that is all for this video. In the next video, we will explore more rules for differentiating more complicated functions. If you enjoyed the video, please make sure to give it a like and don't forget to subscribe. We will see you guys later. Thank you.